Now, I'm going to focus this in tracing some code. We're going to trace it, walk through it, and we're going to focus on something called branch statements. Okay, and I'll get a little bit into what a branch statement is later on. It's effectively an if statement, which you should have seen prior. What I really wanted to get to in this video is I kind of put some of that in there, and I know it took a little bit of time to get through it, but I wanted to kind of make sure that we had talked about variable declaration and variable initialization. Okay. The next thing I want to go into here is looking at something called branch statements. Okay, branch statements. Okay, a branch statement, often referred to as a conditional statement or an if statement, it's a critical component that's directing the flow of a program. Okay, critical component directing the flow of a program. Okay, and what we're going to be looking at here is, let's just look at an example. Okay, here is an example of using a if statement, right? And I would imagine this looks quite familiar to you, even if you've never done anything in C programming before. This should look really, really similar to what you've seen in other languages. Effectively, what we're doing here, right, is we're declaring I equals 5, and we're saying if I is less than 7, then print A to the screen. Else, print E. And what I want to do, one of the first things I want to do is I want to write this in the context of thinking of it as a flow chart. So let's take a look at this example here, right? And I'm going to just free up some room. Okay, let's look at the one really good way of thinking about these things is building it like a flow chart. And what I mean by that, let's just draw it out. Okay, is we can start at the beginning of our program, right? Is main is the entry point, right? So main runs, the beginning of main, we have this, we're going to say I equals 5. Okay, I equals 5. And when we have the if statement, if branches the program, okay? And we're basically saying if I is less than 7, okay, if I is less than 7, we're gonna print A. Okay, we're gonna print A. Okay. Else, we're gonna print E. Okay, so notice we're splitting the program, the flow. It's going to go in one of two directions. It's going to do one or the other, not both. Now in this case, because I is less than 5, it's always going to print A, right? That's besides the point. Right? After note the if and else statement, we're going to combine back together. Okay, and we're going to print. Oh, sorry, not E. We're going to print K and the new line character. Okay. And then the program's going to end. Okay. So we're thinking that the key thing I want to point out here, right? A couple things. Let's look at the syntax, right? The grammar of the language first. If statements, right? We're defining code blocks, right? Everything, if this statement is true, right, if this statement is true here, we're going to run everything in the code block, which is everything from the open and closing curly brackets that are displayed afterwards, right? Notice the indentation here helps us understand what that is. Indentation helps us understand, be able to visualize the code block, to be able to see it. Now, the code, if you don't indent, the program will still work the same way. However, you want to do that, right? And we'll actually have things graded in such a way that to kind of incentivize you organizing things correctly. That's not to be mean, it's to get you in good habits. It'll save you time and make your life a lot easier, right, to be able, because it allows you to scan the different code blocks. So effectively, anywhere you have these curly brackets, you want to indent, and you have this kind of hierarchy where we have this if statement inside of other curly brackets. So for instance, that printf is actually indented twice. Okay. Now, an if-else statement is only going to go and run one of the two code blocks. It will always be one, it will never be both. Okay, it'll always be exactly one if it's an if-else. Okay. In this case, right, because I is 5, 5 less than 7, right, we're looking at a true-false statement. We're basically asking a question, right? Is 5 less than 7? Because that is true, we will run this code block here, and we will print A to the screen. Okay? Now, if I happen to be 12, right, that would be false, and we would run the else code block, right? If I was 12, we would be running this one down here, and we'd print E. Okay? We will always print K at the end, no matter what I is, because it's outside of these if-else statements. Right? Flowcharts are helpful to kind of visualize this and see what's going on. Right? But in this case, what we're going to be printing, right, with I equal to 5, we'll print A and then K. All right? We're always going to be going down this route when I is 5. Okay? Let's look at another example. Okay, now we're doing something. This example is designed to show you if, else statements. Okay, and it's going to look a little bit different. All right, when we're going to kind of write this, let's do it as a flow chart again. Let's write this as a flow chart. And what we're going to see here, right, is once again we're gonna initialize. I'm gonna call it just instead of num tickets, just to make it a little easier to write, I'm gonna call it nt, right, for num tickets equals 6, just the name of the variable. Okay, and now we're going in one of 3 directions because we have this if else statement. So we're splitting the flow into one of 3 statements, okay, where we either print A, print D, or print H. Okay, depending on if NT is less than 5, if NT is less than 10, or if they're both false. Okay, now I want to point out something here. Right, 6 is happens. So well, let's just take it one step at a time. Right, these will then converge back together to print R. Okay. So once again, when we have an if else statement, we're going one of these paths. We will never do more than one, and we also will never do less than one. Right? If we have if, else, we can have many of these else ifs. Right? You can chain them together. Now, how these work is we're looking for the first time something is true. So let's look at this. Right? We check here first, and we say, well, okay, num tickets equals 6. We say 6 less than 5. Right? That's false. Okay? So we're going to go to the next code block, or the next statement, the next thing that we want to check. And then we say, is 6 less than 10? Okay? That's true. Right? So that means we're going to run this code block here. We're going to print D. Right? We're going to print D, and we're going to go down this path. Okay? We're going to print D, and because of that, we're going to skip this code block down here, right? Because if any one of the code block or any one of the conditions is true above, right? That's it. We're done. We're only going to fall into one of those paths. Okay. Now keep in mind if num tickets ended up being say 4, we would have gone down this path here, okay, as the only path because we're checking that first. All right, because 4 is also less than 10, but we're not going to fall into this one because we have an if, else. We're only going to go into one of the statements. Okay, so just kind of keep that in mind. All right, this would probably indicate it a little bit easier to kind of see an example that's kind of like that. All right, so this is different. Notice that now we're not doing anything with if, else ifs or else. It's just all if statements. All right. So let's look at what this would do. Okay. Let's go ahead and draw a flow chart here for this. And I'm going to call this NI for num items is NI just to keep it small. Easy to write. Okay, we're going to say NI equals 5. Okay. And the big difference here is because notice these are ifs, all ifs. They're not else ifs or anything like that. We're going to kind of chain things together. We're going to say, hopefully I can write this in a way that is easy to see, right? We've got this first code block for the if is printing A. And this is going to be if num items is less than 2. We're going to do that. Okay. And we almost kind of have a what we're effectively going to do, right, is we're always going to check each one of these statements here, right? So we also then will say, for instance, if we want to look at when would we ever get to the print F statement, okay? Well, this one is if num items is less than 7, okay? However, if this first statement is false, we're also going to check that, okay? So if num items is less than, is not less than 2, greater than or equal to 2, right? We're also going to say, well, if it's right? If it's less than or equal to 7, where we want to go and print F as well. Right? So it's almost like you could draw it that way, right? Another way to draw it just has more kind of steps along the way. Is we could think of the code almost as converging. So let me kind of draw this a little easier. I think this might be easier to visualize. Is we can almost think of having as a intermediate step. You can almost think of it as having an else, right? If it's not less than 2, it's going to go to this step, and then we're always going to check, right, if num items is less than 7. If it is, we're going to print F. Print F. Okay, and we're going to do something kind of similar for M, right? We're always going to have this intermediate step, okay, and right, if that's false here, we're also going to go. So it's almost like an implied else, right? If we're just going to skip the code block, if the if is false, right? So effectively, like what we're seeing, this might be an easier way to draw it, is we're always going to check each one of these statements, right? And we could go down multiple paths, right? We're going to basically, we look at this and we say num items equals 5. We ask the question, is 5 less than 2? That's false, right? So we do not go into this code block here, right? Then we say, is 5 less than 7? That's true. We print F, okay? Then we're saying, is 5 equal to 5? That's true. We print M, okay? So we can fall into multiple code blocks, right? We can fall into multiple code blocks when they're all ifs, right? You can kind of see this, like what we're kind of getting at with the flow chart, right? Is unlike previous examples where it's split and you're only going down one path of many, if they're all ifs, you've got this sequence where you can be falling into multiple paths, right? Another way to think of this is there's 3 code blocks here. When they're all ifs, you can potentially go into all 3. You could go into any number from 0 to 3, right? Just depending on that, the logic is true or false, okay? One other thing to note, right? I know I'm throwing a decent amount of information at you, is that when we see double equals here, there's a difference, okay? If I have a variable, if I say x equals 5, okay, that's an assignment. That's saying x has the value 5, okay? if I do something like this, if x equals 5, this is checking true or false, okay? This is answering yes or no, true or false. Is x equal to 5? Yes or no, right? If yes, right, go into this code block here, okay? So it's a true or false check, a Boolean check with double equals, right? A very common mistake, okay, is to put a single equals here. If I forgot accidentally one of those equal signs, okay, the code will still compile, okay, but it's going to do something different. It's actually going to set x equal to 5, right, and then it will still fall into the code block, right? It'll still fall in the code block. Very, very confusing and a very easy mistake to make, okay? So if you're setting x equal to something, one equal, right? If you're checking if a variable is equal to something, you're saying, hey, is it equal? Then you have double equals. Okay. All right, so this is getting kind of long, this video. I'm going to break it up and we're gonna stop here.